In this video, we are going to talk about a new objective about the lesson of limits. Objective is how to find the limit or how to study the limit of a piecewise function and absolute value function. Let us take this example. F of x equals x squared when x less than or equal to 3 and 2x when x bigger than 3. That means this function is defined as two domains. The first domain, when x less than or equal to 3, the function here x squared, which means x squared for only the domain less than 3 or equal to 3. That means this function, when x has a value less than or equal to 3, the function is x squared. When x bigger than 3, the function becomes 2x. So we can say here the partition is 3. Now the question is asking us to find the limit when x goes to 3 from the right. So in this case, I have to go to 3 from the right. When I go to 3 from the right, it's clearly that I will meet only one function, which is 2x. That means the limit here of this function will use only the function of 2x. And when I replace x by 3, I get 6. So the limit from the right, when x goes to 3, we take only this part, the right side. Now, what will happen when I find the limit when x goes to 3 from the left? From the left, I have to go to 3 from the left. It means I will use the function which is on the left, which is x squared. So the limit will be x squared, which is 3 squared, equals 9. That means I have two different limits from left and right. If I want to find the limit in general when x goes to 3, not left or right, in general when x goes to 3, in this case I say the limit of f of x in general, since they are not equal, we say the limit does not exist. We say the limit does not exist, DNE. So let us take one more example. Let us take one more example here. I want to find the limit when x goes to 0 from the right. Here the function is defined as x plus 1 when x bigger than 0. So more than 0, the function is x plus 1. And less than 0, the function is x minus 1. That means I have two sub-functions, and each function works on a different domain. Bigger than 0 is x plus 1, and less than 0 is x minus 1. When I want to find the limit when x approaches 0 from the right, of course, I have to take only x plus 1. So the limit in this case will be only the limit when x plus 1. When I replace 0 by 1, I get 1. That means the limit from the right exists and equals to 1. Also from the other side, if I want to find the limit when x goes to 0 from the left, I have to take only the part of x minus 1. So the limit equals negative 1. Since I find different limits from both sides of 0, so we can say the limit does not exist when x goes to 0. But if I take the same function, but when x goes to 1 from the right here, we can see the partition is 0. It means the function x plus 1 works only when x bigger than or equal to 0. So the question is asking to find x goes to 1. So it means 1 here. So if I go to the right or to the left, if I go from the right or from the left, I will use the same function. So I will not use the other function, because when I take values very close to 1, I'm still using the same function, which is x plus 1. So from the left is x plus 1, and I get 2. And also from the right, I will use the same function, which is x plus 1, because it's on the same domain. So in this case, the limit from the left equals the limit from the right, and in general, we say the limit exists. Now let us take some advanced example here. I have a function, piecewise function, that has three values: x less than -4, and x exactly at -4, and x bigger than -4. At -4 exactly, I have the value 8, and less than -4, it is 7 plus x, and more than x minus 4, it is -1 minus x. So if I want to find now the limit when x goes to 0, so I need to see where is 0 in our function here. 0 is here. So I will use only one function, which is -1 minus x. So the limit here in this case, I replace 0 in the function, so I get -1 minus 0, so it is only -1. Now, if I want to find the limit when x goes to -5, we can see -5, it's here before -4. So also from both sides, there's only one function, which is 7 plus x. So I replace 7 plus x, so it will be 7 minus 5, so it will be 2. So the limit equals to 2. Now, if I want to study the limit when x goes to -4, in this case, I have to study two limits, not one, because if I want to go to negative form from the right, I will use the function of -1 minus x, and from the left, I will use 7 plus x. So for the first limit from the right, I will use the function -1 negative x. So I will get -1 -4. So it will be, sorry, -1 -4. So it will be -1 plus 4. So equals to 3. And from the left, I have to use the function 7 plus x. So when I replace 4 or -4, sorry, so in this case, I'll get 7 minus 4 and also 3. So that means the limit exists and equals to 3. Thank you for watching.